Hello, hello, and welcome. Happy New Year. Welcome all to the first Austin Python meetup of the year. It's January 8th, and we are joined here today with Paul Bailey, who's going to tell us all about async patterns in Django, which is fun. Hope you're excited. And I'm just going to hand it right over to Paul.
I'll turn up the volume here. And can you all hear me online since I switched to my mic? Okay, good. All right, let me share my screen. I guess it doesn't matter, but both the same. All right, I think that's coming through. Let's see, can I get rid of it out? Yeah. All right, perfect. All right, so yeah, there's a link to my slides. I actually wrote a book about this topic, so I think we're gonna give a couple away tonight if we can get a list of people and randomly select. But also, I got a discount code if anyone actually wants to buy it. I don't really make any money off these books, so you take a vow of poverty when you write a book, basically. Also, if you don't want the book, but you want all the code from the book and from these slides is actually at that link also, and that's just open on GitHub. So a little bit about me. I'm a former aerospace engineer. I've been coding for 20 plus years or so. I started using Django in version 0.96. I'm currently at Clarity. Like I said, we're hiring. We do financial aid for private schools. So yeah, I posted that link, but also if you're here, come chat with me. We're actively hiring a new team here. Yeah, so that's a little bit about me. I've helped with PyTexas in the past, so I see a few familiar faces. Maybe you've seen me giving a talk or something in the past. I've been hiding out for since COVID, so finally emerging here again.
Welcome back.
Oh yeah, now I used to live in Houston, and now I live in Canyon Lake, so not too far from here.
Great.
Yeah. All right, so let's talk a little bit about Django async. So Django has had like a lot of asynchronous features that some have changed. A lot of stuff has just changed over the many years, and it's finally kind of getting mature. And so I put this together, this talk, but also my book, because there's like, if you do like a Google search, you'll get really confused of how to do things, because there's just been so many different ways of how to actually do asynchronous in Django. And now since it's like built in to the framework, it's actually pretty good. It's still not totally mature. Yeah, question?
So when we do async IO, right, we've got two worlds. We've got clearly most things have like tornado behind them, and all of these tornadoisms sort of sneak up into your code. Or you can be a purist and do pure async IO, and they hide all the tornadoisms. And but the documentation stack everywhere is confused because they all started writing in the tornado context. So nothing is clear, basically. Is the same thing happening here? There's a Django layer of async goodness, and you have mapped it into async IO, or are we still living with Django async goodness?
Yeah, so the old way is basically what you just said, right? And there was actually an asynchronous Django book previously of how to basically hook up Tornado into Django. But it's all built in now to Django, and you don't need to use Tornado. It's built around async IO. Now, it's not totally mature yet. So like, even though there's some asynchronous hooks, like the biggest one is the database. They build in all the asynchronous hooks to access it asynchronously, but it's actually still synchronous. If you want to use that, you got to wait till SciCop 3 comes out, which will be asynchronous. And you can use that today, actually. But I don't think they totally hooked that up in Django yet. But it's pretty mature, and the APIs will probably not change too much. They build out like how you're supposed to do things. So that will probably stay pretty stable now.
So I think you just answered it, but if you were to write against this code now, then the database access is synchronous now, but would become asynchronous as you.
Yeah, so they have asynchronous versions of all the database calls. And so you upgrade the SciCop 3 and then also upgrade your Django. It should automatically, start working in the future. It will work now, but it's just not all asynchronous.
Those were cross fingers I saw.
Yes, yes.
Okay.
So a little bit, if you haven't used the async IO programming in Python yet, right? It's a technique of programming where, it's different than multiprocessing. It's not doing kind of multiple things at once. You're still doing one thing at a time. But if something is waiting, you can go ahead and start something else. So I got a good little chart here, or I thought I did. I'll come back here. This is kind of just like a rough of how many cycles it takes to like do things on your computer. So if you're waiting around for, let's say, something in memory in RAM, that's 250 cycles of your CPU. So you could be doing something else while you do that. Now that's really not a lot, but this is a hard disk. So if you're waiting for something off a hard disk, that's a lot of cycles that you could be doing something else. Or if you're waiting for a network request, right, you could be doing something else. I would say asynchronous programming is harder. So, don't do it unless you have to. And, depending on how you do it, you're not necessarily getting better performance. It just depends. So, don't just go convert all your Django into asynchronous. Especially now, since some of the stuff looks asynchronous and isn't, it's not necessarily going to give you better performance. But, if you're waiting around for network calls, and you can do some other processing, sure, you can start speeding some things up.
I found that just using async IO and simple file IO operations where
Yep.
reading, doing some processing and writing, just getting those onto 3 separate loops, just magically things get faster.
Yep. Yeah.
The OS underneath it is faster. Everything is faster.
Anything with file IO networking, that's probably going to be faster. This is just a real simple example of what something might look like if you converted it to asynchronous. So you have this long running function. It's just taking 10 seconds. So you would, execute the first function, wait for it to finish, execute this long running function, wait for it to finish, and so forth. Where if you did it with asynchronous, you could kick off all of those functions all at once and then wait for them to come back. You still want to wait probably for it to finish. You don't have to. But if you want to wait for all your things to done, they're not stacking up linearly. They can all be shot off. And as the processor gets to them, it's able to execute them. So like this sleep, right? The processor isn't doing anything. So it can do all the other tasks while it's just sleeping. Typically, when you think of asynchronous programming, you think of these keywords to async await, although that's not necessarily the whole deal. And we'll go through some examples. But you add async to your function and it makes it what's called a coroutine. And then when you have a coroutine, you instead of just it returning, you have to wait. And that, I'll go to the next part here. This is typically how most asynchronous loops work. Is so whenever you kick off a coroutine, it's going to put it onto a queue. And so it's not going to execute it immediately. That queue is going to stack up and you'll have a worker that goes and takes tasks off that queue and starts running. Now, if it's something like that sleep or a network call, it can start it and then come back to it. And so while it's waiting for that sleep or the return, it can be doing other stuff. So like typically like JavaScript has like a queue for networking and other things. With Python, we can control this. There's one kind of with async IO. There's usually most people just kind of use one queue, but if you really wanted to, you could start several different queues up and getting to more multiprocessing territory. All right, we talked about the different costs. So again, right, if you're doing something on a disk or doing something over a network, maybe you'll want to do that. Yeah.
You have a really slow machine cycle.
Yep.
Only 240 frames. Multi-gigahertz machine, no, it's way more cycles than that.
Yeah. This chart is very old too. So I used to teach at a boot camp like 5 years ago. And this is from that boot camp.
It was old.
Yeah, it was. All right. So I don't want to just talk about just the asynchronous, putting async await on things and how to use it. But also I want to talk about basically why would you want to use it in Django? And typically for me, it's around because you want to use some of these asynchronous protocols. So if you want to use asynchronous in Django, you can stick an await or an async on your view function, and Django will run it asynchronously. There you go. Like I said, I probably wouldn't go start sticking async on all your views though. But you could do that, and it'll actually just work out of the box. You don't even have to do anything. I believe it will even work if you're running a standard web server, and we'll talk about that here in a second. But these are some of the protocols I'm going to go over and why you might want to actually use asynchronous in Django. Because if you try to use these synchronously, your web server is not going to be able to handle much traffic at all. It'll just get blocked, very quickly. Yeah.
So, in my earlier era, we had the C10K problem, 10,000 connections problem. And that was circa 2000. Okay. Now we're 24 years later. Sure, we still have a C10K problem.
Yeah, sure.
Django has a C3K problem. I don't know. I'm not trying to be nasty or anything like that. What is the record for sustained connections?
Honestly, I don't know what the performance of it is. So yeah.
I mean, it is a mainstream publishing platform, so it should.
I do.
C3K or C10K is a real concern. Right?
Yeah, I do believe you're probably correct. Right, Django is probably more like around 3,000.
I just put that on my hat, so I wasn't trying to be more.
No, that's where like I said, this is more mature than it's ever been, but it's still not totally mature. So.
Absolutely true. Absolutely true. That said, the beauty of these queuing-oriented patterns are that they allow you to increase your open connections. So C10K, C100K problems, all of these things become important, particularly with machines that are so performant. Right? And it's like, yes, it is cheap to spin up a new machine. On the other hand, if your software didn't suck, you don't have to spin up a new machine, right? You really understood asynchronous coding and
I don't know if they have
and stacking work properly. These machines are wicked fast.
And also for that, right? For the 10K problem, basically you're trying to get 10,000 connections in one thread or one core. So yeah, you can always scale. That's why it doesn't always matter. I will talk about this in a second. They don't have any benchmarks. I don't see. I'm sure there's some somewhere. I know I've seen them. I know they're out there. So yeah, the first thing you're probably going to want to use. Now, you don't have to, but I don't know why you would do asynchronous programming and not want to not use an asynchronous protocol so you can hold a bunch of connections open. Because if you use, standard in Django, this is the old protocol, Whiskey. I forget what it stands for now. But the asynchronous version of it in Django is, ASCII.
Wasn't it server gateway interface?
Yeah, something like that. Yeah. So the first thing you want to do is probably run your Django server in an asynchronous manner. So these are kind of the three options that you can choose from, outside of the development. This one is a Daphne, is based on Twisted, I believe. So if you're an old soul, you can use Twisted. Hypercorn, I haven't used that one this much. I kind of prefer this guy here. So have you all heard of the new package manager UV? So yeah, the package manager. So UV is the kind of new hot package manager for Python. That's really fast. It's built on the same library, the same event loop technology as that package manager, if you've been using it. Which actually I believe comes from JavaScript. So this basically takes like the JavaScript event loop, and then you're able to run your asynchronous Python on it. So anyway, this is really fast. And so maybe we could hit 10,000 connections. Like I said, I haven't looked at the benchmarks. All these are kind of drop in, you just got to pick one. The one advantage of Daphne is it supports HTTP 2.0. And there's some features with that we'll talk about later. So if you want HTTP 2.0, use Daphne. All right, but first let's talk about some of the protocols that you might want to use. So the first is WebSockets. That's not to be confused with just sockets, networking sockets in general. WebSockets is like a standard that was built for web browsers, basically, so that you could send data in both directions. So it's a bi-directional web protocol. You can use it outside of the web now, though. It's not just in web browsers anymore. It is kind of based on HTTP. So you'll see actually the first thing that gets done when you create a WebSocket is it starts an HTTP connection, and it does, I think it's a 101. It asks for an upgrade. And then basically if the upgrade is accepted, you now have a pipe, a socket that's open where you can send data back and forth between the two. And then at some point, you close that connection. So back to our web server, you can pretty much plug any of these in and not have to kind of worry about it, and you can just start using them. Like you can just install them in your project and you're good to go. But if you want to do a WebSocket, Django is not actually, doesn't have like some of the piping, I guess you could call it, built in by default to use a WebSocket. So you have to go in, if you're familiar with a Python or a Django project, there's a whiskey.py and there's an ASCII.py. So you actually have to go in and you have to add this little piece to your application. So your normal application, so you'll see something like this in that file. Actually, let's just go to a piece of code here. So if you have a Django project, yeah, I'll enlarge it here in a second. So this is typically what you'll see. So this is the whiskey.py, but the ASCII.py, it looks similar, right? So Django produces this when you start a project, you'll get one of these files. So when you're using a WebSocket, you have to add on to it. So the original app that's there is your just normal HTTP app. So you'll want to add something like, if it's a WebSocket, and you'll have to create a WebSocket app. And I'll show some of that here in a second. And then if it's not a WebSocket, just send it through to your regular HTTP app. So you have to do a little bit of custom routing. Yep.
What's the advantage of using WebSockets again?
It will keep a connection open. So like if you're doing something that's getting updates, let's say, so if you're like polling for updates constantly, you could use a WebSocket, just keep that pipeline open, and then just send data as it is.
And you don't have the HTTP overhead every time.
Yeah. Now you have different problems because you'll have a bunch of sockets open all the time. So you'll have different scaling problems. But if you're like trying to do like real-time updates, you could send data as it comes through instead of as you're polling for it. So you just keep that open, and it's bi-directional too, right? So you could also send updates from, let's say, the web browser over as they happen in real time also. So that's a little bit of the setup here. Let's look. I think I have, let's see. Okay, so that's a normal one. I'll pull up one of the WebSocket ones. WebSocket examples here.
What I'm seeing is that Django makes it easy to also be a website client.
Yeah, it's not a lot of extra routing you have to add, but you do have to go in there, and most people don't ever touch this file. All right, so this is where I made it easy. So I also wrote this library called Django WS. So if you want to make it real easy, you can install this, and basically this, just add those 2 lines to your ASCII file. And then also what I'm showing here in an example only gives you one WebSocket. So maybe you want multiple WebSockets on different URLs. So this library will also kind of set it up so that you'll have URLs for your WebSockets. So you can have separate WebSockets if you want. So that just basically simplifies the whole process for you.
So I have just the one example that I've, worked at a place that was using WebSockets. There was an auction website, and each client who was in the auction had a WebSocket. So for that, we would need something more like the solution you just showed us, because you want one WebSocket open.
Potentially, some like a lot of projects. Typically with WebSockets, you don't have as many URLs just because of the way things get designed. So maybe you just do one WebSocket. Maybe for each auction, you just send over the auction ID or something, and then you start streaming the data. So it just depends how you want to.
You could design around that.
Yeah, you don't necessarily have to. I've done a lot of Node work too, and actually most of the Node projects that I use WebSockets with, they never have a URL. You just have one WebSocket and send everything through it. So it just depends. I think it's kind of nice to have the option to do some different URLs. Yeah. So.
URLs, but for load balancers, no choice.
Yeah.
Right.
Yeah. Like I said, you'll have different scaling problems too, right?
Yeah, well, I'm thinking that you'd only have a REST service, not a socket state.
So
I suspect there's all sorts of it out there.
Oh, yeah.
Okay.
So in terms of performance, right, you'll have to you're holding a lot more memory open because you're holding these connections open. So the scaling becomes different.
What's another computer? To scale it all.
All right. So if you use the library that I came up with, there's also other libraries that have done similar stuff. This is actually what Tornado kind of looks like. I just did it in Django, made a library that kind of copied it. This is what your WebSocket will look like. So, and you have different events. So you have an on open event. When you first connect to the WebSocket, you can do something. This might be a good place to do some authentication. Maybe you want to authenticate that they can actually connect. When they send a message to you, you'll get the on message event, and you can do something. If you want to send them some data, you can send them some data, and then you also have an on close event. The other thing you might want to do on open is maybe you start a process. So for that auction site, maybe you start a process where you do a listen notify on Postgres and have it stream you new bids. So that's where you might want to start that process so that as new bids come in, you can stream them to the user.
Broadcast.
Yeah. So you want to be careful though, right? Because these are all asynchronous. But if you do something that's going to block your process, you do something non-asynchronous. So this is where asynchronous becomes like hard. Once you do like one thing asynchronous, you want to do like everything asynchronous. I call it, you're going down the asynchronous rabbit hole, because if one thing blocks, if I put like a sleep here that blocks, then it's going to start blocking everything.
Or Postgres access right now might be synchronous. Right?
Yeah, that's going to block things. Yeah. Although, your database is probably fast, so it's not going to matter too much, hopefully.
If you do the whole thing in asynchronous, but then you use the gcloud command, their standard library, it's not asynchronous. There's a third-party library that does asynchronous. So if you store anything to a bucket, that's your longest step, save the file.
Yep.
That's the whole thing. Let's use.
Yep.
Let's use how asynchronous.
Yeah. So if you store to the bucket and you're storing something on that server, right, and it's a huge file and it's not synchronous, then you just made your asynchronous code not performant, just as bad as your synchronous code, right? So you got to be careful. If all these things that you're doing in here, you want to start doing them asynchronously. All right, so that's kind of.
That raises.
Yeah.
a question. With Async IO, I've been able to like take big chunks of blocking code and just say, you run on a separate thread. And there's a high level function that just does that. Like a script. Right? Pretty much.
Well, it's not. As an async, it's not another thread.
Well, yeah, but there's IO is overlapped properly. It's overlapped properly, and everything just starts flying. And we get a lot more. I get a lot more. And it sounds like there's still lots of sensitive pieces down there that I didn't realize were still down there. Okay, because I've had great success just taking these big blocking chunks, just put them on I forget what the call is, but so it basically puts it on its own background and away it goes. It runs fine. And basically it lets all the other stuff run. And it pretty well. But it sounds like that if I go all in on async, there are things that can block everything.
Yeah. So just code.
So here's a good example from the code. That GitHub I linked. So this is a weather app that's basically pushing the current weather to your web browser. So here's the WebSocket. So I actually wait for the web browser to tell me, hey, send the weather. And then I start sending the weather. And so in my library that I wrote, I have this thing called a start task, which is what you were just talking about. Basically, I'm going to start like a background task. And if I would have wrote this as just a function, it would block everything. Instead, I'm going to write it as a background task. And so I built this in. You'll see this in the Async IO. There's things called tasks. So I just wrote a little wrapper around it. And so this is going to start my send weather task in the background. And then you can see my send weather task is sending the weather asynchronously and then doing a sleep. So, but when it's sleeping, it's also doing it asynchronously. If I would have just done a time.sleep there, it would start blocking everything and I'd be back to square one. So you got to make sure you do everything asynchronously or you'll start blocking other processes.
What's the plan of the sleep then?
For this one, I'm just checking it every 3 minutes. So
You're waiting for the browser to say, hey, send me the weather, and then it sends the weather
every 3 minutes, yeah. So every 3 minutes, I'm sending it the newest weather.
When you start a new task with start task, do you start a process or do you start a thread?
So it's actually the asynchronous thread is already running. So it's just putting another task on that queue, basically.
So it's another thread. Okay, thank you.
It's in the current thread. It's the same thread, but yeah, it's actually not a new thread. It's just using the same one that's there.
Just waiting for pauses in between the things
Yep.
that you're doing and just mixing in with more small little. Thank
Yep.
you.
Yeah, so if you go back to this picture, right, it's just putting another task on that queue.
There's one thread for this queue.
If I'm just using the default, and if you do the same, you'll have one thread. Now, if I wanted to, I could start another thread. That's up to you. But if you just kind of use the default stuff that's there, you're actually only ever using one thread. You're just adding stuff on that queue.
Thread can go off and do other things
Yeah.
based on this queue, but you're still just using one thread.
Yeah, so when I put that sleep on that queue, it's on the queue and it's just going to wait 3 minutes.
So you're still only
And-
doing one thing at a time because
Yep.
it's one thread, but
Yeah.
you're not sitting there doing nothing.
Yeah. Yeah, so, right, if I was blocking at that point, so if I had a blocking sleep, where'd my code go? That one thread would be blocked. Nothing else would be
Would not
happening.
only not be doing this, it wouldn't be doing
It
anything.
would be doing anything else. So now that I
Thank you.
now that I do it asynchronously, it's putting it on the queue, it's going to sleep, it can start doing other stuff. So it can start getting 10,000 more connections. And maybe those connections aren't doing anything, but at least they're getting connected and waiting. They're on the queue now to get processed. So if you're doing Python, right, and you're kind of hitting a bottleneck and your CPU isn't really going any further, let's say it's like at 50%, you could start doing some asynchronous coding to get your CPU to kind of get more utilized, go closer to 100. All right, so that's a WebSocket in a nutshell. There's a lot more. Like I said, if you want to go through my code or the book I have, this is the example, the WebSocket examples in here. WebSocket weather. All right, next. So this one, again, I don't know necessarily if you'd want to. I've done some WebSockets in Django, and they work pretty good. I don't know if you would actually want to do this in Django, but here it is. Streaming, because typically when you think of streaming, right, you think of like video or something large. And even though I think, in theory, it should be good.
I have to
Yep.
ask, did you write your own streaming code instead of using a library in this case?
No, you'll see here in a second. It's part of Django.
Oh,
So-
okay.
Yeah, but I just don't know, since it's Python. I don't know if you're going to get like the best performance. But if you have I've actually wrote like a small media server that did streaming in Django for my personal use, and it worked fine. I could stream music and videos. I didn't have like a lot of people using it. So I don't know. I don't know if this would be your first, yeah. Yeah.
There's not computation on Python.
Yeah, so I think it should be okay, but anyway, Django supports streaming now, and it's pretty easy. You'll want to use this, like I said, if you have like a big file, a video, something that you want to send in chunks, right? If you try to send one big chunk at once, you're going to block your processor, right? And so other stuff can't happen. But if you send it in small asynchronous chunks, then while you're in between, you can be doing other stuff. So, the real quick way is Django has a streaming HTTP response now. They actually have had this before, but now it supports asynchronous iterators. So you just give it an asynchronous or a coroutine. And then in that coroutine, like I said, you don't necessarily have to do it this way, but then it's going to block. You just asynchronously send chunks of whatever you're sending through. So if you have a large file or video, just send it in a few chunks at a time, and it will do it asynchronously, and it won't block other code from running. This right here is if someone, closes that tab or something and it gets canceled, maybe you want to clean up or do something like that. But this is pretty easy. It's just, you just have to give your streaming response a coroutine, and it will, send that data through asynchronously in chunks.
How long is a long-lived HTTP connection? It's like 60 seconds.
Sure. I mean, for me, like anything more than like 3
Really?
seconds is probably long.
Is there like a standard for like?
No, it's just long,
Okay.
because typically HTTP, when they connect, get your data and then close it out.
Sometimes I've heard of it like it's long if the user is going to think that it's not working.
Yeah, that's why I say like 3
Like,
seconds.
psychologically, if nothing happens for a little while, then the user is likely to mess with it.
But
So
for-
there's code for that.
Yeah, for this kind of thing though, like a video, right? It's running in the background, and since it's streaming, right? Think of your YouTube, it's just getting a chunk at a time. It can start playing the video, even though the HTTP hasn't finished yet.
HTTP stuff, though, it's just TCP.
Yeah.
It's not more expensive to run the stream through HTTP.
Yeah.
It's not the same as HTTP2 with, multiplex.
Yeah, I was wondering, is it HTTP2 feature or is it
No, this is just standard.
Just TCP.
Yep.
Any TCP site. There's nothing
Yeah.
rocket science here except it's rocket science.
You could do this forever in Django. There's been a streaming response. The only difference is in the newer versions, it supports coroutines. So you could do this before and just return chunks, but it wouldn't actually do it asynchronously. It just build it all up and then send one big chunk over. So yeah, that's the only difference between this now.
build and send at the same time?
Yeah, so while you're sending, so every time you see this yield, it's actually sending a little bit.
Building the larger for
Yeah.
For
So-
rocket sites before, there's probably a separate streaming server. They do a redirect of the URL.
Yeah.
And stream off of that, whether that was Python or Django, or whatever, it could be whatever it might be. Now you could actually build a small site that probably is performant.
Like you said, I don't know, maybe I haven't benchmarked this, but I think theoretically it should be fine to do it in Python. It should be fast. I'd love to see a benchmark about, I don't know, maybe the next YouTube's is written in Django. So.
Yeah,
I
because
just-
you'll get 3 or 4 users, and so it'll be fun.
Yeah. I just kind of put that in the beginning when I started talking about this because, if you talk to like a lot of people, they're going to say, well, if you're writing a streaming server, it needs to be Rust or Go or something. So I don't have high expectations, though. In theory, I think this should be pretty performant. So
Whenever the computer is low compared to the I/O, then Python is great.
Yeah. So
There's really a diet, this is IO dominated. Because streaming is almost
Yep.
by definition.
Yep.
dominated.
Yep.
Depends on how much cash you want to throw at it. But that's the problem that every streaming server has.
Mhm.
How much cash you want to throw at it.
We can get more computers. There's some more-
you don't need, you can do it all from your laptop. Just throw it in a data center. All right. Any other questions about streaming? That one's pretty easy. You just have to have a coroutine and do a streaming response.
You don't have enough scotch, sorry, go on.
All right. This is kind of the lesser known one. And anyone ever use server sent events? Yeah.
Like Dash, Poly Dash.
Okay. So this actually came out about the same time as WebSockets, but WebSockets, everyone just loved WebSockets, so this got eclipsed. And this is actually a lot easier to use, but it's only one direction. So like with your auction example, if the data is only going one way, this would be a better.
Right. And if you want people to be able to update their bid,
Yeah.
then this will not do this.
Yeah. So like a chat server would be better with a WebSocket because you have messages going back and forth. But if you just have bids coming in, this is a lot better. It's just a one-way. It's very simple. It's over an HTTP connection. I actually wrote out the whole protocol here. So if you're familiar with HTTP, that those top 3 lines are the header. So you just got to make sure you send over the right header, which is text event stream. You give each event a name. So you have different types of events. And then your data can actually be anything. I put in some JSON. And what happens is you just keep that HTTP connection and you just keep on sending events. Now, like I said, you could actually do this before in Django, but because you're holding that connection open, you would start blocking everything. But if you do it asynchronously, you can put something on the queue, and then that way other stuff can process and send the next event through.
Are those event names arbitrary?
Yep, you can call them whatever you want. You don't have to send JSON. You can send whatever kind of data you want. This first part of it is the protocol. So event and data. Actually, you don't even need to have an event name if you don't want to. So really, the only piece you have to have is data. So it's going to look for data : something, and that's an event. I like giving it names.
Can data be a file object or?
It could be text. You know, it could be like a base 64 encoded file or something like that. Yeah, it could, I believe it supports binary data. So yeah, you could just send binary data through. Yeah.
Can you use this to stream data like a video or something?
Yeah. Yeah. Yeah, if you really wanted to. And the browser knows from this header to keep the connection open. And actually, this gets really annoying with your browser because so with a WebSocket, sometimes you do want to close it. If a WebSocket gets closed, say you lose your network connection, the web browser is not going to open it automatically for you again unless you have it do that in your JavaScript, right? With a server sent event, the browser will actually automatically try to reopen it constantly. It tries to reconnect.
Or a feature, depending on...
It gets kind of crazy if you have a bug and like your browser just going crazy trying to reconnect. So yeah, it will just actually try to reconnect if it crashes. Again, I wrote a little library to kind of make this easier, to make it more simple. And yeah, all you do, again, you could actually just, if you wrote a little, did like a HTTP response and just put this in the body, you would have a server sent event. But I made a little library around it so that you can create a stream and then just send it JSON events. So again, you want to use an asynchronous coroutine, and then you just yield events as they happen. You'll notice, and you probably saw this maybe in the WebSocket, I put a ping every so often with no data. Some hosting providers will close your WebSocket or your server sent event if no data comes through for a minute. So it depends on where you deploy to. So sometimes it's good to just send a ping through or empty packet every so often so that your connection doesn't get closed. So, you know, again, you just, for this one, it's the same weather app as that WebSocket, but instead of sending it through a WebSocket, it's just yielding events, going to sleep, looking for the next weather event, and then yielding that event. And then doing a ping again, and then waiting for 30 seconds. So it's just sending events constantly. Yeah.
Is the client-side code for this or a WebSocket significantly different than just using a HTTP request?
It's a little different than HTTP. Well, the WebSocket is a little bit different. So when you do a WebSocket, there's a WebSocket class in JavaScript. For server sent event, actually, I believe it's the same thing. Because it's just an HTTP request. But let's see here. I haven't looked at this in a while.
What's the bidirectionality of the sending data back? That's like the complicated part.
Oh, okay, no, I misspoke. Okay, so there is an event source. So that's a server sent event in JavaScript. And then every time you get an event, you add that event listener. So every time you get an event, that's going to get called. I was thinking of the next topic, which is long polling.
Evil.
So this is real simple, right? And that's all that's happening. It's just an HTTP request that's continually sending. The browser knows to keep it open because of the headers you sent through. Now there are some limitations. If you're using HTTP 1, the browser only allows 6 server-sent event connections from one domain. And that is for all your open tabs. So you can see, like, I have 5 tabs here. If they were all in the same domain, it only allows 6 server-sent events for all of my tabs. So you can run into limitations if, like, someone forgets, right? If you're one of those people who has a million tabs open. I know we have some here.
I was put on the spot to demo something today. I just showed my screen and I was like, I have no idea what
Yeah, we know you're out there. Now, if that's where it goes back to, though, if you use HTTP 2, there's no limitations. So it's only HTTP 1. So that's where to go back to the beginning here. If you're using server-sent events and you want HTTP 2, you might want to use Daphne.
So the others don't support HTTP 2?
Not yet. No, they don't.
That is surprising. That Unicorn would still not support HTTP 2.
Yeah. Not. I mean, that I haven't checked in a while, but yeah, last time I checked. So, yeah. And I guess to put a little caveat, I actually tried to use HTTP 2 in Daphne, and I couldn't get it to work. So maybe, but in theory, they list that HTTP 2 works on Daphne.
So you listed 3 there, and you said Daphne had the best support. There isn't one that has better HTTP 2 support? Daphne?
Not that I could find, no.
Here it says.
I haven't checked in a while.
October 2nd, 2024. Unicorn supports HTTP 2.
Okay, there you go. You see, I haven't checked since the summertime. So yeah.
So at least one developer has gotten it.
That has been in 2017.
Yeah, HTTP 2 has been around for a long time.
Yeah.
I think what it was is that up until some of these new asynchronous features in Python have come out, you really haven't needed HTTP 2 for anything. So
Never had a headline problem.
yeah.
Yeah, I mean, HTTP 2 can do some like serious black magic.
Yeah.
Yeah, there's like some really crazy stuff to do with it. It's a bit like sneaky that I don't really understand very well. Honestly.
Well, one of those magical things is more server-sent events. There's no limitation on it. All right. So now we're going to talk about long polling. So this was actually kind of a hack before WebSockets, before HTTP 2, before WebSockets came out, before we could have, that bidirectional communications. And so this is just HTTP, but it's the hack in that you keep it open. You keep that connection open until you have data to send, and then you send it over, it closes, and then you start a new one. So that's what this diagram is showing. So you do a request, in my weather example, you wait maybe that 3 minutes for that new weather data point to come through. We send it through, and then the browser immediately, when it gets the data, starts a new request, and it just hangs there until it gets the data. Like I said, this is kind of a hack and kind of the old way to do things, but there are still some firewalls that don't allow WebSockets. So a lot of times for technology, or and I'll talk about some of these services out there, they still do long polling to kind of get around firewall issues.
I'll do this so I don't have to deal with WebSockets.
Yeah, it can simplify it can simplify your code base. Yeah.
This is a technique from
This is a
the
technique,
dawn
not a
of
hack.
days. This is
Yeah.
the dawn of Unix.
Yeah. So this is just a normal Django view. You know, of course, you want to throw that asynchronous. And again, right, you could do this before, but now that we have asynchronous abilities in Django, you can do this without blocking the rest of your code, right? So that long wait period, we can, you know, do other stuff. So this is just a, you know, simple Django view. We pull up the weather, we wait, and then at some point that loop gets broken, and then we return the weather. And then the browser, the client side code, is going to reconnect and then do that long wait again. So the reconnecting part of it is on the browser side. I can show that. So that's where this code just looks like a simple HTTP request. See that. So it does the post request to that URL. And then you can see when it gets the data, it just calls itself again. So it's just continually calling itself. So you can see the beginning of this function, it's getting the response. Go away. It's getting the response, setting the value for our UI, and then sending another request through. So it just keeps on calling itself. So that's long polling. Yeah.
Django can do it all.
Yeah, so now, well, it could do it before, but now it's not going to suck.
It sucks.
Yes. All right, so now that is kind of all of the, I went over kind of all the like low-level examples of like all the low-level protocols. There's other protocols that you can build on top of this. So there's like, if you're a GraphQL person, there's a GraphQL subscriptions, which I have actually in this code base. But that's just GraphQL on top of a WebSocket. So if you want to look at some of those examples, that's in here.
There's a GraphQL endpoint in Django.
Mhm.
And turns around and does GraphQL query to whatever database infrastructure and sends it back.
And then so if you use a GraphQL subscription, you can keep that connection open, and that query, as it gets updated data, sends the new data through as it comes in. So I went over kind of like all of the like lower level basic protocols, and basically, you know, this is the Python code, or, you know, how you would do it in Python. With that said, you might not want to do it in Python, and you might just want to buy yourself out of this problem. And these are actually really good options. So I'll go over this one first. So Pusher is a asynchronous service that basically does like all of the WebSocket stuff for you. And if we look at their Python, you can do these asynchronous protocols, but in your Python, you're just doing synchronous code. So instead of having to worry about keeping that WebSocket open, you just call Pusher and you do an event to that channel, and they handle the rest of it for you. And so you're not worrying about doing some of those low-level protocols.
Is that channel though, like a client server channel, or is that just like some workable operating?
So you can set it up several different ways. With this particular example, you're pushing this event to that channel. It could be a public channel that everyone's subscribed to. It could be a private channel. Depends what you want to do. Ably is another service that does the same thing as Pusher, basically. Just a competitor.
AWS SQS, the simple queue system.
Well, I would say it's more simple. It's more than simple, because with Pusher, like if you do like a public channel, it's doing the scaling for you in terms of broadcasting. So you can push one thing and then it goes out to like multiple.
Whenever people mention Pusher, I feel obligated to make sure it's a paid product.
Yes, it's paid. So Pusher and Ably are paid. Third one I call is Sockety, I guess. Is a free service you can go run yourself that is compatible with all the Pusher protocols. So if you want to do it yourself on your own server, run Sockety, and you can use the same mechanism.
So just to see if I understand, so what you're doing basically is you're putting it on a queue, but this queue is on someone else's server.
Yep.
So therefore, it's very quick because it just gets back the answer. Yes, I put it on the queue.
Yeah, all you're doing, right, is you're basically just pushing the data, and then they handle the WebSocket and pushing it out to multiple clients if they want. So yeah, you're paying for
them to handle a queue.
Yeah.
So.
Or in this case, if you use Sockety, you're not paying, but you're deploying this as like a layer, right, to kind of do all the asynchronous stuff for you.
Potentially on a different machine, I suppose.
Yeah.
Machine and a DevOps load and
Yeah.
all of that other sort of stuff.
Yep.
Yeah, risk everywhere.
If depending on what you're doing, if you're doing like a broadcast, these can help you kind of scale, because eventually you'd have to do that with your Python code, right? And they already have it figured out.
The beauty of what you're saying is that Django now, with more async capability, can increase its connection count.
Yep.
Which actually helps you defer these decisions till later.
Yes. Yep.
That's the big one. Push that decision off.
Mhm.
Wait till Pusher goes out of business so that you don't have this business.
Yeah.
Yep. And that's actually some of the code I'm working with now. We've done a WebSocket and we're starting to get bigger now. And so we're thinking about, but we've done, the WebSocket was built 2 years ago when none of this stuff was kind of in place. So it's in Node, but we're still having the same problem of like, okay, now we got to scale this. But, it helped us because that feature was in Node. It helped us defer that decision. So now maybe we'll use something like this.
Do you think the Node implementation or the Django implementation is scaled better?
I don't know. I'm guessing the Node probably scales better just because it's more mature. But I think Django could probably do it just fine. It'd probably just work just fine.
Scaling questions are really hard to answer. Like you need to, it's kind of just complete speculation unless you have like some numbers. It could be like, and when I think talking about what you expect, like, and like scale, it can also depend a lot on the application. Basically, like it's hard to compare apples to apples. So I would, if you actually have scale, like a lot of people have like premature scaling concerns. Like some salespeople told them like, oh, we're going to sell like 2 million to 2 million customers. Say, okay, great. Like that's not a scaling concern. Like if you have actual scaling problems, then you have actual numbers, and you should run those actual numbers before.
The more important thing, I wish we would have had some of this stuff 2 years ago.
Yeah.
Because it forced us to use Node for our WebSocket. And so now we have all this Python backend stuff. And now we have some Node backend. And so we got a mixed code base.
Yeah, I was just thinking that the answer to the question of whether Node or Django does it better is probably depends on how much Node knowledge do you have and
Yeah.
how much Django knowledge do you have. in
So
your
we
house.
have all this Django knowledge, and if this would have been in place 2 years ago,
I was actually.
I'd rather
gonna
just
ask
keep it there,
you.
you know.
Well, that's because if Django is within 2x performance of the node, get rid of the node.
Yeah.
Right, it's really very simple.
Yeah.
JavaScript people,
Especially-
okay, get rid of them, simplify your stack, scale it up as much as he
Yeah.
wants, okay? But the bottom line is you're simplifying your whole surface of complexity. Right?
I think for how we're using it, I think it would have been within 2 to 3 times.
So you can
Yeah.
still replace.
Yeah, yeah, that's also.
Well, now we got a whole
But
code
we
base.
got JavaScript, it's like, okay, like, the other questions, does that come with JavaScript developers, or does it come like, I'm not sure what's worse, having Python developers maintain JavaScript or having JavaScript developers.
Not sure, but the diversity, if it really is a question that we now have the async capability of Django, the Django shop, they also have node implementation just for WebSockets. That is just added complexity that is going to hurt your scaling and your ops store.
Yeah.
It's going to hurt your ops store, and you can fix your ops store.
It led to architectural decisions that are difficult now, 2 years later. All right. Oh yeah, and this is just that's that same pusher example I showed you, right? So, query for weather, connect to your client, and then just push it through some channel, and then pusher does all the magic of broadcasting it or sending it to just a private channel, however you have that set up. All right, so that's all. There's the links. Did you want to? Yeah, let's do it. Okay. Yeah. And if we have the online people, I have an ebook I can send them to.
Okay. I have an idea.
Okay.
There's some new people here. There's some old people here. You can come up. You say your name. You put your name down on the spinner here, and then we'll spin for a free book. And I'll start. And I'll say, "Hello, my name is George. Thank you for coming."
Perfect.
And thank you, Paul, for that. That was so much fun.